Hello everyone, this is Mr. Fawcett and I want to welcome you to our first lesson in our geometry curriculum. Today we're actually going to take a step back and we're going to see how much we have retained from Algebra 1. There's a lot of skills that we need to bring into geometry to be successful, and probably the biggest one is being able to solve equations correctly as well as efficiently. So today we're going to throw a bunch of different one variable equations at you, or a bunch of different types of those equations, and we're going to see what to remember. And you may find that there's types of equations that you need some refreshers on. And you'll have plenty of time to get some extra practice in if that is the case. Before we get started though, let's talk a little bit about what I expect from you for these videos. They're not meant for you to just watch them without doing anything else, right? So you should have your notes in front of you. You should be working out the problems as we go through them. You should actually be pausing the video and working out the problems before we go through them. So whenever you see me about to start a new problem, hit the pause button, read it yourself, and see if it's something you can do on your own. And then once you've attempted it, press the play button, see if your work is correct, or if you really had no idea how to do it, you can then listen to an explanation. But I really encourage you to sit there and, perhaps struggle through some of your thought processes first before you just get the right one. I know it's satisfying to, be able to just put the correct answer down and see the correct work, but a lot of what is becoming a good mathematician is trial and error, and that productive struggle. So it's in your best interest to attempt these problems before just listening to what I have to say about them. You'll notice that they're also only going to be about 15 to 20 minutes. There'll be times where I have to make multiple parts for a lesson. That's okay. I don't want to just give you a 45-minute video. I know that can be cumbersome. So even though the videos are 15 to 20 minutes, with your pausing, rewinding, replaying, they may take you 30 to 45 minutes to get through one of them. So let's jump in and we'll see how far we get in this lesson for this first video. We're going to skip, at least on the video, we're going to skip what's up here. I just threw a bunch of different equations at you. These are the types of equations we're going to look at solving today. You can kind of go through and rank those in order of how difficult they seem to you to solve right away, but you don't have to go ahead and solve them. The first thing we're going to do in the lesson is go through a bunch of different equations. We're going to solve them in the left-hand column, and we're going to write out the steps in words in the right-hand column. So geometry, at least this class, is going to be pretty heavily proof-based. So you're always going to be justifying your work, explaining what you did. A lot of times you'll do it on paper. Sometimes you'll do it verbally to a classmate or to myself. But that explanation part has to be there. So not only do I want you to know how to manipulate equations using symbols, I also want you to be able to explain what you did. So here's your first chance to pause the video. You can do this one, the entire next page, the entire next page, and the entire next page, and then go back and rewatch the video. Some of these may be very straightforward for you. Some may be a little bit more difficult, but don't skip that right-hand column of writing out the steps. Take time to do that. It's only going to benefit you more in the long run. Once you've given each equation a good faith effort, come on back, start the video, and then you can see how you did. Okay, so for our first problem, we have a quadratic equation here. X squared is equal to 36. So when we're solving equations, our goal is to get the variable by itself. So in this case, we need to get the x by itself. So we need to use what we call inverse operations to do that. And right here, we need to figure out an inverse operation to undo this square. Well, the inverse operation of squaring something is square rooting something. So I'm going to square root both sides. So I'm going to get x is equal to the square root of 36, which is 6. But here, you actually have to remember, we have two answers here. We can actually have plus 6 or minus 6. So whenever you take the square root of a number, you're going to have two roots. You're going to have a positive and a negative, unless you take the square root of 0, which is just 0. If you're confused about why we have two answers here, well, let's go back and think about it, right? Let's go back up to our initial equation. If I substitute in positive 6, I get 6 squared is equal to 36, and I get 36 is equal to 36. That checks out as correct. If I try negative 6, I get negative 6 squared equals 36. Negative 6 squared, if I square a negative number, it's going to become positive. So I get 36 is equal to 36, which is true. So both of these solutions here, negative 6 and positive 6, are correct. Now, there's not too many steps here, but we do have to write them out. And for these steps, I'm actually going to likely just pause the video, so you may see the steps just pop out on the screen rather than me writing them out. That's just going to be to save time for the video. Okay, so our only step here was to square root both sides, and then I just put a little asterisk that says, remember that you have a positive and negative root here. Okay, let's move on to the next problem. All right, so if you haven't already done so, solve the equation on the left-hand side, write out your steps on the right. Okay, so first step here is, and sometimes you can do steps in a different order. My first step is going to be to distribute. So if I distribute that 5, I like to draw my arrows to make sure that I distribute to every term. I'm going to get 5x minus 5 is equal to 3x plus 13. And we'll write out the steps after we go through and solve the entire equation. My next step is I need to get the x's on both sides, right? Because I need to get the x by itself. That requires me getting the x's on both sides. Otherwise, I'm never going to have just one x by itself. I'm going to have an x on both sides. So I'm going to subtract 3x. And that's going to give me 2x minus 5 is equal to 13. Then I'm going to add 5 to both sides. That's going to give me 2x is equal to 18, and then I'm going to divide by 2. So I get x is equal to 9. So for this lesson, I would encourage you to write out every single step. I know it seems a little tedious. I know you may feel like you're proficient with solving any type of equation. You can just kind of skip these steps. Again, because it's our first lesson, we're getting our feet wet again for this year as far as solving equations go. Write out the steps. Once you've proven to me that you are proficient, then you can start to skip the intermediate steps and not have to write them down, because I know that some of you can just compute those mentally, which is fine. That's what we're working towards, obviously. So now we're going to write down our steps in words. All right, so our first step was to distribute. Our second step was to subtract 3x from both sides. Our third step was to add 5 to both sides. And our fourth step was to divide both sides by 2. Now, it's up to you whether you want to write out these steps as you go or whether you want to do them at the end. Either way, they just need to be there. All right, on to the next one. All right, so this time we have a quadratic equation again. So maybe that lets you know there's a possibility we get two solutions here. All right, so when I see a quadratic, and especially one that has, so a standard form of a quadratic is ax plus bx plus c equals 0. Whenever you have this middle term, or sorry, ax squared, whenever you have this middle term, the x term, there's a couple different ways you can solve. Probably the easiest one is going to be factoring. So you can always check to see if you can factor. If you can't, you can then try graphing on your calculator if you have access to a graphing calculator, or you can try the quadratic formula. But we're going to try factoring. I'm also going to give you a short review on factoring, to hopefully help you out. So first thing I need to do, if we look at this equation, we need to set it equal to 0. So I need to add 20 to both sides. So I'm going to get x squared minus 12x plus 20 equals 0. Of course, I can't add the 20 to the negative 12x or to the x squared because they are not like terms. Now, once I have this equation set equal to 0, I can now start to factor. What I like to use is called a factor sum chart, so an FS chart for short. I'll write out the actual words here, but you can just use F and S once you understand what's going on. So when we factor, we are trying to find factors of the C term, so factors of 20 that sum is another word for add, to the B value, which in this case is negative 12. So factors of negative 12, numbers that multiply to give us factors of 20, so numbers that multiply together to give us 20, and that add to negative 12. Now, we just use a chart because it helps us stay organized. So I can test some factors. I have 10 and 2, I've got 4 and 5, I've got 1 and 20, and you can just add these together to see what you get. Now the problem is none of these sums are negative. I need to get a sum that's negative 12. So what you may notice is that this first set of factors gives us a positive 12. But what if I change them both to be negative? Well, negative 10 times negative 2 gives me positive 20, which is what I need, and negative 10 plus negative 2 gives me negative 12, which fits both requirements. Okay, so once you have the two factors, we write them out as x minus 10 times the quantity x minus 2. Okay, maybe that looks familiar, maybe it doesn't, depending on how far you got in Algebra 1. Now I have two different equations I can solve. So, well, let's back up, I guess. Right now I have a product. I have two factors that are being multiplied together. That's called a product. Now, if either of these factors that I underlined is 0, then the entire right side, or the entire left side rather, is going to be equal to 0. And that's because anything multiplied by 0 is going to be 0. So if the left factor, x minus 10, was equal to 0, it wouldn't matter what the factor x minus 2 was, because 0 times anything is going to be 0. Likewise, if x minus 2 was equal to 0, then it wouldn't matter what the other factor was, the one on the left, x minus 10, because it would be being multiplied by 0. So if I can get x minus 10 to equal 0, or x minus 2 to equal 0, I will have a true equation. So what I can do is set up two different equations. X minus 10 is equal to 0, and x minus 2 is equal to 0. And I can solve both of these. So add 10 to both sides here. I get x is equal to 10. And I can add 2 to both sides here, which is going to give me x is equal to 2. So both of these solutions are correct. Now, if you want to check your factoring process, so if you want to make sure that this is equal to this, well, you could distribute and draw your arrows in this equation. So I could do x times x times negative 2, negative 10 times x, negative 10 times negative 2, and see if we get our blue equation up here. So that's just a way to check. All right, so let's now write out our steps. All right, so again, just to reiterate, our first step was to add 20 to both sides. Once we had our equation set equal to 0, we could then factor using the factor sum chart. Then we wrote our two equations where each factor was set equal to 0. That's what we did right here. and then we solved both of those smaller equations to find our two solutions. Okay, let's see how long our next problem is going to take. And we are going to just do a part 2 to pick up where we left off. Again, I want to keep these videos between 15 and 20 minutes. So I look forward to seeing you next time. We'll pick up with some fractions, and we can continue looking for where we need some extra review from Algebra 1. All right, this is Mr. Fawcett. Enjoy the rest of your day.